Hello, I'm 2180101 Khairul Anwar. Today I'm going to talk about the introduction for wind turbine. Firstly, the important aspect in this topic is wind energy. Wind energy is created when the atmosphere is heated unevenly by the sun, causing some of the air to become warmer than others. This warm air rises and other air rushes in to replace them, hence causing the winds to blow. In 1888, Charles F. Rush has invented the first wind turbine in Cleveland, Ohio, which had 144 rotor blades and made out of cedar wood and generates around 12 kilowatts of energy. Wind turbine is a device that converts kinetic energy from the winds into electrical power. Basically, how wind turbine works is by extracting the energy from the wind by transferring the momentum of the air passing through the wind turbine rotor into the rotor blades. The rotor blades are called aerofoil and used for concentrating the energy in the airflow into a single rotating shaft. There are two types of wind turbine. The first one is the horizontal axis and the second one is the vertical axis. For horizontal axis, there are three specifications, which is a single blade, two blade, and three blades. For vertical axis, there are the Darius and Sovonius wind turbine. Each type of the turbine has its own specification and purposes. For horizontal wind turbine, the wind stream is parallel to the rotating axis, but for vertical axis, the wind stream is perpendicular to the rotating axis. There are also different sizes for the wind turbine. From the diagram, we can see the different diameter and power generated, ranging from 70 meter diameter that generates 75 kilowatts to the 100 meter diameter that can generate 3000 kilowatts of electricity. Okay, next I'm going to talk about the advantages of wind turbine. Firstly is renewable energy because the energy is harvested from the wind. Secondly is the wind power is cost effective. Unlike conventional method, it does not need to burn fossil fuel to generate power. Thirdly is no greenhouse effect because wind turbine doesn't release any gases to the environment. Lastly is it can be set up in remote area which can help to power houses that is too far to have normal power lines. Next, I'm going to talk about the disadvantages of wind turbine. First one is prediction of wind speed. Wind speed varies from time to time. This may reduce the ability of the wind turbine to generate power at its highest capacity. Next is high initial cost. Wind turbine is very expensive to build due to its large in size. Third one is threat to wildlife. The blades of the wind turbine poses a threat for birds because they tend to get hit by the blade. And lastly is it requires large amount of land. Usually a wind farm uses up large amount of open area or farm area to operate.
Okay, hello everyone. I'm Kubendran, son of Angamuthu, and I'm here to talk about designs and specifications of a wind turbine. Okay, let's go. Okay, there are many wind turbines designed based on only two types of axes around the world. The first is horizontal axis turbine, known as HAWTS, and the second one is a vertical axis turbines, known as VAWTS. Parts and major parts function. Okay, as you can see here, got a picture which labels the parts and the on the wind turbine, and the first one is the wind direction. As you can see, the blue color arrow, this arrow shows the air direction, and the second is a rotor here, and the third is pitch, the pitch here, which can change the direction around 90 degree, and the fourth is low speed shaft. Number four is the low speed shaft, this blue color shaft, and the fifth is gearbox. As you can see, this one, the yellow, and six is a generator here. This is a generator, and the seven is a controller. Okay, the seven is a controller. Control the speeds, to control the generator, all. And the number eight is an anemometer. Anemometer is this one. Okay, and the nine is wind vane here. This is indicates the direction of the wind. And number 10 is a nacelle. Okay, nacelle is a type of shell which covers the all the components. And number 11 is a high speed shaft. Okay, this is the high speed shaft besides the generator. And number 12 is the tower. Here is the tower, as you can see. And number 13 is the blades. Okay, and 14 is a yaw motor. Number 14, this is the yaw motor. And the number 15 is yaw drive. Number 15 is a yaw drive which drives the motor, and number 16 is a brake. Okay, here I listed down the major parts function. The first is the foundation, and the second major part is the tower, and the third major part is a rotor. Rotor is the rotating part of a turbine and consists of three blades mostly. Next is the major part is hub. The hub holds the blades in a position and able to rotate with respect to the rest of the turbine body. Okay, next is nacelle, and final is generator. As you can see, the generator converts the mechanical energy of the rotor to electrical energy. We're going to see the most common turbines in the world. The first is GE 1.5 megawatt model, and it is horizontal axis turbine, and it has 116 foot blades, and it made from 212 foot tower, and it weighs more than 164 tons. And second is the Vestas V90, and it is a horizontal axis turbine, and it has 148 foot blades and also 262 foot tower, the height of the tower, and it weighs about 267 tons. Okay, next we are going to see the innovative wind turbines. So the first innovative wind turbines made are quite Revolution QR5. Okay, it can function with less wind, and it is a horizontal axis turbine, and it is in helical design and can collect the wind same amount in every direction. And there are 70 turbines installed at Dagenham, a suburb of London, and this turbine can generate between 4,000 and 10,000 kilowatt per year. Okay, next we are going to see the wind spear. It is called wind spear turbine, and it is a vertical axis turbine, and it has thin propellers rotor. This is a thin propellers rotor. Okay, and it can spin its vertical air force. Okay. Next, we're going to see the Megan air rotor system, as known as Mars. This is a model of a Megan air rotor system, and it works at high altitude, and it is a horizontal axis turbine, and it is a plot with a helium field.
So let's go through the theoretical aspects of the wind turbine. First law is familiar and commonly used to overcome this system. First law indicates the maximum power that can be extracted from the wind independent of the design of a wind turbine in open flow. It was published in 1919 by the German physician Albert Betz. The law is derived from the principle of conversion of mass and momentum and idealized actuators that extract energy from the wind stream. According to Betz's law, no wind turbine can capture more than 19/27 of the kinetic energy of the wind. The factor 16/27 is known as Betz's coefficient. Practical utility scale wind turbines achieve at peak 75 to 80% of the Betz limit. In order to understand the process of wind energy conversion, it is made useful to represent the wind turbine rotor in a simple way as a disk. So what happens to the wind flow in the presence of this disk? If the disk is free to move with the wind, it does not exert any force on the flow, and therefore the wind is completely undisturbed. In this case, no energy is extracted from the wind. In other side, if the disk is fixed, it tends to oppose the wind flow by exerting a force T on it, and the flow is disturbed. In particular, the flow is slowed down by the force T, and at the same time it tends to go around the disk. Energy can be extracted from the flow if both the force T and the wind velocity just behind the disk are non-zero. Thus, the disk should not block completely the flow. Instead, it should allow for some wind to go through the disk, which is open disk porous. We will see shortly that this has some consequences on the number of blades and also rotational speeds of the rotor. The power extracted from the wind at the disk can be found by the equation shown, which is equal to the product of the force T and the velocity at the disk. This is why both quantities should be non-zero in order to extract power. Considering the disk represent the wind turbine rotor, the wind velocity and the disk is denoted by UR. In summarize, we have seen that if the disc does not exert any force on the flow, the velocity at the disc is maximum, but the power extracted is zero. By contrast, if the force exerted by the rotor maximum, the velocity at the disc broke to zero. Therefore, the power is also zero. Thus, it should be an optimal condition of force T and velocity at the rotor that maximize the power. It can be shown that the power is maximum when the velocity at the disc is two-thirds of the incoming wind speed. This means that the rotor acts as a porous disc, exerting a constant force on the flow, while still letting two-thirds of the flow through it. In this case, the non-dimensional force exerted by the rotor is 8/9. With this value, the power extracted by the rotor is 59.3% of the total power available in the wind at the location of the rotor. In other words, the non-dimensionalized power coefficient is 0.59. This is called the Betz limit. Although this model represents a very simple approximation of a wind turbine rotor, it is an effective way to describing the global effect that the wind flow has on the rotor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ain Zul. My matric number is 2180149. Today I will talk about conclusion. From the research that we have done on this topic, we can conclude that wind energy is one of the most promising renewable energy resources for power generation and rapidly grow until nowadays. To convert wind energy into electrical power, we use wind turbine. The wind turbine is a machine that converts kinetic energy from the wind into the electricity. The wind turbines is manufactured in two types of axes, which are horizontal axis turbines and vertical axis turbines. Each design has its own function and specification. Even each axis has its own advantages and disadvantages. Although the majority of the wind turbines nowadays have a horizontal axis. Because of technology's advance, wind turbines has been improved their designs and become more innovative and more environmental friendly. There are certain fluid mechanic issues involved in the design of optimal wind turbine, such as aerodynamic, unsteady aerodynamic, wind characteristics, and many others. For wind turbines aerodynamics, it concerns the modeling and the prediction of aerodynamic forces, such as performance prediction of wind farms and the design of specific parts of wind turbines. Another theories or laws that involve is Benz law, indicates the maximum power that can be extracted from the wind. Independence of the design of a wind turbine in open flow. Lift and drag forces are also involved in the process. The combination of these two can cause the rotor to spin. By using wind to produce energy have few effect on the environment that many other energy sources. Wind turbines do not release emissions that can pollute the air or waters and do not require water for cooling. Wind turbines may also reduce the amount of electricity generation from the fossil fuels, which result in lower total air pollution and carbon dioxide emission. However, while there are a number of environmental benefits to using wind energy, there are some downsides. Firstly, wind energy is intermittent, as the wind turbine's effectiveness in generating electricity depends on the weather. One of the biggest downsides of wind energy is the noise and visual pollution. Lastly, wind turbines have some negative impact on their surrounding environment, as the wind turbines blades are very large and rotate at very high speed, and it can harm and kill species that fly into them, like birds. Wind energy is probably the best solution for our energy demands. It has a great potential and easy to manage. Every wind turbine lasts for about 20 to 25 years. As long as the wind blows, wind turbines can harness the wind to create powers. Unlike coals or fuels, wind turbines don't create greenhouse gases and completely renewable energy. Though wind turbine can cause complaints and fatalities of wildlife, but it can improve using current energy, and it could be the best energy sources and electricity.